Question is, the internal energy of a system remains constant when it undergoes. Option A is cyclic process, isothermal process, adiabatic process, or any process in which the heat given out by the system is equal to the work done on the system. We know that in the indicator diagram, which is a PV diagram, if a process is cyclic, that means it takes a complete turn. That means it starts from A and end at the A, then we will say it is a cyclic process. So in a cyclic process, because initial and the final point is same, so we can say its internal energy is same. So we can say here for this process as a whole, the internal energy is a constant. Similarly, if we draw a PV diagram for a isothermal process, then process will be like this. And for isothermal process, temperature remains constant. And if temperature is constant, because U is a function of temperature, so its internal energy is also constant. Therefore, we can say that internal energy of the system is also constant for the isothermal process. So A is correct, B is correct. Now we check the adiabatic process. If we check the adiabatic process, its indicator diagram will show is the graph is like the isothermal but with greater slope. Here slope of the adiabatic process will be larger, and in adiabatic process the process take place so fast that delta Q equal to 0. It means there is no exchange of heat. If heat is supplied to the system, then its temperature increases, or if heat is withdrawn from the system, its temperature will decrease. In that case, if temperature changes, we can say that its internal energy, which is a function of temperature, will also change. So in this process, the internal energy will not remain same. So C is not a correct option. Fourth option is any process in which the heat given out by the system is equal to the work done on the system. Here heat is given out by the system. So we can say in this case delta Q will be less than 0, that is it is negative, because heat is given out by the system. It is given to the system, then it will be taken positive. And also work done on the system. If work is done by the system, then it is positive, and here work is done on the system, so work is also negative. Now using the first law of thermodynamics, that gives delta Q equal to delta U plus delta W, and here delta Q is equal to delta U, and both are negative, so they will get cancelled, or we can say delta U equal to 0, or this implies that because there is no change in the internal energy, we can say U is constant, internal energy is constant. Hence option D is also correct. Therefore answer of the question is A, B and